Previously in the other video, we talked about the volume of pyramids and cones, like just the basic following the formula. Now we're going to use it to apply with real world problems and some additional type of problems right here. Okay, so number 5. Determine the height of a cone that has a diameter of 10 inches and a volume of 225 inches cubed. So let's see what we need to find. We need to determine the height of the cone. That's important. It has a diameter of 10 inches. And the volume is 225 inches cubed. So because I'm dealing with a cone, I could go ahead and use that volume formula. So remember, the volume is just 1/3 times the area of the base. So because it's a circle, the area of a circle is pi r squared, and you multiply that by the height. So let's go ahead and plug in what we have. So we have here that the volume is 225. So I'm going to replace that with V. The diameter is 10, but I need my radius. So remember, radius is half of your diameter, so mine's going to be 5. So I'll have 5 squared. And then the height, I don't know, I'm looking for it. So right now it seems kind of messy. It's like, oh boy, how are we going to solve this? So here's what we're going to do. First, let's just take care of the exponent like you normally would. So let me write it over here. 225 equals 1/3 pi 25, and then times your h. 1/3 is a fraction. This is not in a fraction form. So remember, technically this is all over 1. So you could just rewrite this. It's the same thing as saying it's like 25 pi h all over 3. That makes it easier to solve. So I'll have 225, because 1 times everything is just going to be 1. So you're going to have 25 pi h all divided by 3. That's the same thing what you're doing. Okay, and now to solve, we're going to solve for h. So I want h to be by itself. But right now, it's trapped in this fraction. I want this denominator to go away. Now, you always ask yourself, what's the operation? So you do the opposite. So this whole thing is being divided by 3. So you're going to do the opposite operation, which is going to be multiplying by 3. Whatever you do on one side, you have to do on the other. So that could divide out. So right now you're going to have 675 equals 25 pi times h. So no more fractions, now it's free. Now, just to recall, pi, remember, it's a constant. It's just a number. So saying 25 times a number times h. This is your coefficient of h. I want h by itself. So because it's being multiplied, we're going to go ahead and divide both sides by 25 pi. So I'll bring it over here. Divide both sides by 25 pi. If you're going to leave it as 25 pi when you divide, just make sure you do 675 divided by, open parentheses, 25 times pi and close parentheses, okay? Or you can multiply it out right now. So when you do that, you'll get the height will be 8.594, blah, 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 keeps going. I'm going to round to the nearest hundreds. And I'll just leave it like that because you're not rounding up. So the height will equal to 8.59 and the units are inches. I'm not putting cubed because it's not the volume. The volume was here. This is just the length. And not the length, it's the height. So I mean, it's just a dimension. So you just leave it as that. So that's the height. And if you always double check, if you plug this back in here times your 25 times pi divided by 3, you'll get 225. So that's a way you can always check your work. Okay, so next. At Shower and Body Works, there are different sizes of lotion dispensers. 2 of the versions are shown below. Bottle X, bottle Y. How many times more lotion is bottle X than in bottle, how did I read that wrong? How many more times more lotion is in bottle Y than in bottle X? Now, we're talking about lotion being filled up in this dispenser, right? That is volume. So this will be a volume of a pyramid. And we're going to use that formula. We're going to do for bottle X and then bottle Y. So let's go ahead and do that. So let's go ahead and work on bottle X. So bottle X, the volume is going to be 1/3 times the area of the base times your height. Okay, so let's find the area of the base. This is a rectangle, so the area is length times width. So for the big B, it's going to be 2 times 1, which will just equal 2. So that's for the area of the base. And then I multiply by the height, which they told me is 6. So the volume for bottle X is just going to be 4 inches cubed. So let's keep that in mind. That's bottle X. Let's go ahead and find the volume of bottle Y. We have, again, the same formula. This is also the base is a rectangle. So for the area of the base, it's length times width. 3 times 1.5. Oops. When you multiply that, you get 4.5. 4.5 times the height, which is 4. Multiply, multiply, then divide by 3. The volume for bottle Y is going to be 6 inches cubed. How many times more lotion is in bottle Y than in bottle X? Keywords. Times more. So notice not saying the difference. What is the difference between bottle Y and bottle X? It's not saying that. So let's look over here. So we have bottle X, which was 4 inches cubed, and bottle Y was 6 inches cubed. How many more times is bottle Y compared to bottle X? When you look at it, it's kind of like difficult just to see it right away. So let me do a little side note here. Let's pretend example. If I had 4 and 8, how many more times more, how many times more is this bottle compared to here? Well, it's 2 times greater because 4 times 2 gives me 8. Right? If you just see it that way. But let's pretend I didn't know that. What if I didn't know 4 times 2 is 8? I want to know this times something gives me 8. So if I'm multiplying to figure it out reverse, I'll be dividing. So if I did 8 divided by 4, I would get 2. So then it tells me, okay, 4 times 2 is 8. That's how many times greater it's 2. So same thing here. We can't just think of 4 times what gives me 6. It doesn't come easily. So we're going to divide the opposite. So I'm going to go ahead and do 6. Okay, so it's 6 divided by 4. And it'll equal to 1.5. So how many more times lotion is in the bottle Y? It's 1.5 times more. Why is that S so far away? And then for part B, which bottle is the better buy? Is it bottle X or bottle Y? Now, if you're looking at the volume, you'll be like, okay, well, this one has more volume. But let's look at the price for how much you have in bottle Y. Is that price reasonable? And look up for bottle X. Is that price reasonable? So let's go ahead and look. So let's talk about bottle X. Let's do the price per unit, like meaning like, you know, here you have 4, that's the volume, but what is the price per unit, like for each little volume? So bottle X is 996. What? No. What the heck? I'm sorry. It's $9.96. What is going on with me? Okay, so for that one, for bottle X, it's $9. That's too expensive, it was the other way. $9.96 for 4 inches cubed. So when you divide this, you'll get $2.49 per unit. So we're going to put them in the equivalent form. That way we can see is it worth which one to buy. Next, look at bottle Y. Yeah, it's more expensive, but is it worth it? Because you get more. So let's see. Bottle Y. The price there was $14.90. I'll make sure I said it right this time. $14.90. And the whole volume was 6. So what is the price per unit, like per one volume of it? When you divide that, you get $2.40. Let's compare. Which is the better price? This one's a better price. And guess what? You even get more volume, you get more lotion in that. So the better buy would be bottle Y. Bottle Y is the better buy. And finally, we have one more. Got part A and B though. Monica sells lemonade over the summer and uses conical paper cups to serve the lemonade. Each cup is 8 centimeters in diameter and 11 centimeters tall. She starts with a 10-gallon container. 1 gallon is equivalent to 3,785 centimeters cubed. Determine how many paper cups are needed to empty the entire 10-gallon cooler. Okay, so it's a word problem. Let's highlight what's important. So skim through it again. So this is important. It's conical paper. That's the shape, so we know. Cups. Each cup, so it's 8 centimeters in diameter. It's very important. 11 centimeters tall. And she's using a 10-gallon container, and this is important. Notice we were in centimeters, and this one was in gallons. So that's important. Now they're telling you 1 gallon is equivalent to 3,785 centimeters cubed. So that's what we're going to need. Now for part A, we need to determine how many paper cups are needed to empty the entire 10-gallon cooler. So that means you have a big cooler and you're trying to dump it into those cups. So let me go ahead and draw it. It's 8 centimeters in diameter and then it's 11 centimeters tall. So 11 centimeters. Let's go ahead and use the volume to find the cone. They give me the diameter, so the radius is half of it, which will be 4. And the height was 11, like they said. So do your exponents first. So you get 16, and then multiply by 11 times pi divided by 3. And I'm going to just leave it to the nearest hundred. So it'll be 184.36, blah, 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 blah. So nearest hundreds, I'm going to round it there. So because it's greater, it's 5 or greater, you're going to round up. So my volume for those little cups of cones is 184.31 centimeters cubed. Okay, next, the cooler. We need to figure out the cooler. We have the cooler is in gallons. It's a 10-gallon container. So how much is it for centimeters cubed? That's why they helped us. Now, if you're thinking about it, all you're really doing is just, okay, so if 1 gallon is equivalent to 3,785, you're just going to multiply this by 10. Now, to make it easier, if you want to visually see it, this is the reason behind it, because you're doing like a proportion. So 1 gallon is equal to, like they told me, 3,785 centimeters cubed. That's what's given, right? So if I have 10 gallons, I will put it in a proportion. It'll be right underneath gallons. So gallon to gallon. So it's 10 gallons. How much would it equal to in centimeters cubed? So this is your proportion. You cross multiply when you have to solve for x. So you have 1 times x is x. And notice, you see, all you're doing, like I said, you're just going to multiply 10 times 3,785. So the volume here is going to be 37,850 centimeters cubed. That's the cooler. So you want to know how many cups does it take? Well, this is how much has to be emptied, and this is how much the volume of each cup is. You want to know how many paper cups you need. You're going to divide to find that amount. So we're going to do 37,850 divided by, so that's the total amount that you're filling up, and this is how much 1 cup, the volume of a cone, so 1 cup. This is the cup. That's how much you could fill 1 cup. So how many cups are there in total? You divide. So you divide, you'll get 205.36. So how many cups? You need about 26 cups. How many paper cups are needed? Did I put 26? How's that? Oh my goodness, it's 206. What is wrong with me? 206. Yeah, that makes more. Okay, so you need about 206 cups, I'm sorry, to empty the entire 10-gallon cooler. Because that was just, remember, that was just the volume of 1 cup. So you want to write that down, 1 cup that you need. So that's how much you need, 206 cups to empty all of this. Next, for part B, if the conical cups are solid in packages of 50, how many packages are needed to be bought? I need 206 cups. 1 pack is 50, so how many packs do you need? You divide it out. So I'm just going to do 206 divided by 50. You get 4.12. So let's think about this. Is that going to be your final answer? I'm going to go to the store and get 4.12 back. That doesn't make sense. So you always round up. So in this case, you don't use your decimal to round up. You just have to make, okay, well, I need an extra package of cups because I need 5. You need 4.12, so you need a little bit more. So how many packages are need to be bought? 5 packages. So because these are real world problems, I'm just like, oh, find the volume and stuff like that. Make sure you take account for what you need and if it makes sense or not. And that's how you find the volume of pyramids and cones. Just some examples with like word problems.